Hey everyone, in today's video we're going to be talking about parametric equations. So a parametric equation defines a curve by expressing the coordinates x, y as functions of a third variable called the parameter, which is usually denoted as t. So in a parametric equation, x and y are defined separately in terms of t. So the parametric equations are x equals f of t and y equals g of t. So when we graph parametric equations, first we can start by making a table with the variables t, x, and y. And we have this domain restriction for t, which is between -2 and 2. So we can pick values for t between -2 and 2. So we can do -2 for our first one. And then for t equals -2, we can plug that t value into each of the equations. So for the x coordinate, it would be -2 squared minus 2, which is 2. And then for the y coordinate, we'll plug it into the other equation, which is -2 plus 1, which is -1. We can do t equals -1. So for our x coordinate, it will be -1 squared minus 2, which is -1. And then for our y coordinate, it will be -1 plus 1, which is 0. For t equals 0, we have 0 squared minus 2, which is -2 for x. And for the y coordinate, it would be 0 plus 1, which is 1. For t equals 1, we have 1 squared minus 2 for x, which is -1. And for the y coordinate, it'd be 1 plus 1, which is 2. And finally, for t equals 2, we have 2 squared minus 2, which is 2, and 2 plus 1, which is 3. So when we graph this, we'll only graph the x and y coordinates. So like the x and y values here. So our x values go up to 2 and down to -2. And our y values go up to 3 and down to -1. So for t equals -2, we have -2, 2, -1. So this one, which is 2, -1. So we can graph 2, -1, which is here. For t equals -1, we have -1, 0, which is here. For t equals 0, we have -2, 1, which is here. For t equals 1, we have -1, 2, which is here. And then for t equals 2, we have 2, 3, which is here. And then we can connect the points. And then we can draw arrows to show which direction that this is going in. And we'd go from -2 to 2 for the t values. For this next example, we can again start by making a table with the t, x, and y values. And we can start with t equals -2 since we have this domain restriction. So for t equals -2, our x coordinate would be -2 cubed minus 2 times -2, which is -4. For our y coordinate, it would be 2 times -2 plus 1, which is -3. For t equals -1, we'd have -1 cubed minus 2 times -1 for your x coordinate, which is 1. And for y, we would have 2 times -1 plus 1, which is -1. For t equals 0, our x coordinate would be 0 cubed minus 2 times 0, which is just 0. And then for our y coordinate, it'd be 2 times 0 plus 1, which is 1. For t equals 1, our x coordinate would be 1 cubed minus 2 times 1, which is -1. And our y coordinate would be 2 times 1 plus 1, which is 3. And then for t equals 2, we would have 2 cubed minus 2 times 2 for x coordinate, which is 4. And our y coordinate would be 2 times 2 plus 1, which is 5. So when we graph this, we'll only graph the x and y coordinates. So our x values go down to -4 and up to 4. And our y values go up to 5 and down to -3. So for t equals -2, we have the coordinate f -4, -3, which is right here. For t equals -1, we have 1, -1, which is here. For t equals 0, we have 0, 1, which is here. For t equals 1, we have -1, 3, which is here. And then for t equals 2, we have 4, 5, which is here. So we can connect the points. And then draw arrows to show which direction this is going in. So next we're going to talk about eliminating the parameters. So that means that we're converting the parametric equations into one Cartesian equation. So to do this, first we can solve for t in this x equation. So we'll get x minus 1 equals 2t, and we can divide both sides by 2 to get t equals x minus 1 over 2. So then once we have t, we can substitute that into our y equation. So y equals t squared, which is t is x minus 1 over 2 squared minus 4. So this means that it's x minus 1 squared over 2 squared minus 4. So we can expand the x minus 1 squared. So we get x squared minus x minus x plus 1, which is x squared minus 2x plus 1. So on our top, we would have x squared minus 2x plus 1 over 2 squared, which is 4, minus 4. So we can simplify this by making this minus 4 a minus 16 over 4, because when we subtract, we have to have a common denominator. So we can make this a minus 16 over 4. So that would equal y equals x squared minus 2x plus 1 minus 16, which is minus 15 over 4. And that would be our Cartesian equation. So next we have parametric equations with cosine and sine. So when we have this, we can use cosine squared theta plus sine squared theta equals 1. So we can solve for a cosine. So we can do x equals 4 times cosine theta. We can divide both sides by 4 to get cosine theta equals x over 4, but we want the squared. So we would square both sides of this so that we would get cosine squared theta equals x over 4 squared. And then for sine, we have y equals 3 sine theta. We can divide both sides by 3. And then we can square both sides to get sine squared theta equals y over 3 squared. So this would equal 1. So we'd have cosine squared theta, which is x over 4 squared, plus sine squared theta, which is y over 3 squared equals 1. And then we can simplify this, so we have x squared on the top and 4 squared, which is 16 on the bottom, plus y squared over 3 squared, which is 9, equals 1. And this shape is an ellipse. So next we have x equals 3 cosine theta and y equals 3 sine theta for our parametric equations. So we can again use cosine squared theta plus sine squared theta equals 1. So we have x equals 3 cosine theta, and then we can divide 3 from both sides. So we get cosine theta equals x over 3, and we can square both sides to get the cosine squared theta. We also have y equals 3 sine theta. We can divide both sides by 3, get y over 3 equals sine theta, and we can square both sides to get the sine squared theta. So we would have cosine squared theta, which is x over 3 squared plus sine squared theta, which is y over 3 squared equals 1. So this would mean x squared over 9 plus y squared over 9 equals 1. We can multiply both sides by 9. So we would get x squared plus y squared equals 9 for our Cartesian equation, and this is a circle. So next we want to find a set of parametric equations given the graph of this Cartesian equation using the parameters x equals t. So we can substitute this x equals t into this. So we would have y equals x, which is t squared. So you'd have y equals t squared and x equals t as the parametric equations. Next, we have the parametric. We want to find the parametric equations for the graph of y equals x cubed plus 2x using the parameters t equals x plus 1. So we want to solve for x here. So we'd have x equals t minus 1. And then we can substitute that into here. So we'd have y equals x, which is t minus 1 cubed, plus 2 times x, which is t minus 1. So we can expand the t minus 1 cubed by first doing t minus 1 times t minus 1, which is t squared minus 2t plus 1 times another t minus 1, which is t cubed minus t squared minus 2t squared plus 2t plus t minus 1. So we'd have y equals t cubed, and then negative t squared minus 2t squared is negative 3t squared. 2t plus t is 3t minus 1 plus 2 times t minus 1. And then this is 2t minus 2. So our final equation would be t squared minus 3t squared. Oh, right, this is the cubed. So t cubed minus 3t squared, and then plus 3t plus 2t, which is 5t, and then negative 1 minus 2 is negative 3. So this would be one of our parametric equations, and we also have x equals t minus 1. So for our final example, we have an application problem where a ball is launched from the ground at an initial velocity of 40 meters per second, and this would be v0 from here at an angle of 30 degrees. So this would be theta, because theta would be the launch angle with the horizontal. So using parametric equations, determine the position of the ball xy at any time t, ignoring air resistance. So we have these parametric equations. So we can substitute the values in. So x equals the initial velocity, which is 40, times cosine of theta, which is 30, times t, and y would equal the initial velocity, which is 40, times sine of theta, which is 30, t minus half g, which is 9.8 t squared. So we can simplify some of these values. So x would equal, so we can type 40 cosine of 30 into our calculator. So it would be, we would get our decimal form, which is 34.641t, and y would be 40 times sine of 30, which is 20, t minus half times 9.8 is 4.9 t squared. So next we want to find how long it takes the ball to hit the ground. So to hit the ground means that the vertical position would be 0, and we can see here that y would be the vertical position. So that means that to hit the ground, y would be equal to 0. So we can use this equation and substitute 0 for y. So 0 equals 20 t minus 4.9 t squared. So we can use the quadratic formula for this. So negative b, which is 20, plus or minus the square root of b, which is 20 squared minus 4 times a, which is negative 4.9, times c, which is 0, since there isn't a c value, and all of that over 2 times a, which is negative 4.9. And then when we when we put this into our calculator for the plus the square root, it would be equal to 0. And then for the minus the square root, it would be equal to 4.08. And so it can't be 0, so it'd be 4.8. And it's in seconds. So 4.08 seconds. Oh, to hit the ground.